Hi there, this is Dr. Pan recording from Tucson, Arizona. Hope life is treating you well. Thank you for watching this clip on conics for coneheads. This is the last part. We're dealing with hyperbolas here. Let's get started. So we're going to be completing square. Let's gather all the x's together. And here's minus y squared equal to minus 4. Okay, let's pull the 2 out here, x minus 2x. I'm going to add a number, subtract a number, so I can finish my completing square. This is equal to minus 4. 2, and then x minus, what I'm going to put in here is minus 2 over 2 squared. So each one has a 1. X minus 1 here, minus y squared equal to minus 4. Okay, so I have 2 minus 1 minus 2 here, minus y squared equal to minus 4. Let's move the minus 2 over, so I have 2x minus 1 squared minus y squared equal to minus 2. Now what I'm going to do is divide by minus 2 on both sides. Then this one becomes a positive one, so it's a plus y squared over 2 minus x minus 1 squared over 1 equal to 1. Okay, the reason I have to do that is I have to normalize it here. Now, the positive term is y, so curve is on positive term. And in our case, it's y, so the curve is going to look like that. I always think of the hyperbola as kind of like a broken arrow. The really important thing is you find out where that asymptote box is. Okay, this is the box that settles the curves. So let's take a look at here. I have b, or equal to radical 2. This is the term here. Or you can call it 8. It doesn't really matter so long you keep track of which one is where. Let's draw, and then the curve center of the curve is at, I have 1, positive 1, and 0. Okay, so positive 1 and 0. The one I got over here is basically x minus 1 equal to 0. That's this term here. Okay, so let's draw a curve with a box here. And the radical 2 is 1.4, so it's a little over 1. And x is 1. So here's my box. Once I have the box, I have my asymptotes. Okay. Asymptotes gives me the curves. So here's my curve. 2 branches. Well, actually, my apology. This curve is actually on the y-axis. So actually, it goes this way. Yeah, got ahead of myself and forgot what I was doing here. So here's my curves. It's on a y because y is positive. Okay. Now the center here is not at 0, 0. It's 1, 0. So basically I need to shift it over. And this is my x and y axis. Here's the x. Here's the y. So here's the curve. I went on to the wolfgram and plotted it as well. And you can see here's our center. Okay, here's that box I was drawing earlier, and that gives the asymptotes. And here's your 2 curves. So this is how we start. So when we are drawing hyperbola, we're really looking for this box, and boxes from the coefficient we have. Now, math break. Let's take a look. Now, I got my National Geographic today, and I could swear those are desserts, but they say it's rare stones. Could have fooled me. Alright, back to math. Let's go on to the next one here. Next one is where we started last time in part 3. I have a 9x squared minus y squared plus 18x plus 6y. Now in part 3 we see that this side was 0. Now I changed this number into 9 to show you that by changing this one number here, instead of degenerative when it's 0, we have actually a parabola. So I'm going to skip the part where I actually did the completing square. I'm going to get down to the part where I completed square on the left-hand side equal to 9. Okay, so from here I'm going to divide it by 9. So I have x plus 1 squared divided by 1 minus 1 minus 3 squared divided by 9, which is 3 squared, equal to 1. Now this term, x term is positive. X term is positive. So curve is on x-axis. That means the curve is going to look like this shape instead of what we did for the other one. Now again, looking for the box. The box, I have a equal to 1, b equal to 3. So let's draw it out. And let's see. And center is at when x minus 1, x plus 1 equal to 0. So that's minus 1 and positive 3. Because this point is minus 1, positive 3. And then curve is on x. And let's see. Curve is on x, and this one has 1, and the other one has 3. 1, 2, 3. So here's my box. It's a little bit out of shape, but hopefully you get the idea what's happening. So here's a curve. So once again, I took the dimension. This is the negative part, which is 3. Okay, positive is 1, so this is the 1 unit, and the curve is on the x-axis. Okay. And then since it's minus 1 and positive 3, my original, so it should be here and done. So curve, my x-axis should be right here. I'll show you what the computer-generated graph is. So here's the curve. Here's the x-axis. Here's the y-axis. Let's go on to take a quick look. All right, here's the graph. All right. Once again, from Tucson, Arizona, this is Dr. Pan, making learning math fun. At least trying to. If the video has been helpful, I would appreciate a comment or a thumb up. Until next time, have a confident day.